5 seconds, I'll speak.
Okay, did you, Micah, did you see the screen on your screen to make the YouTube alive? Because you have a button there too.
No, but it is live.
It's already been done, Liana.
Okay.
Okay, well, welcome to San Francisco Bay Area ACM event. Tonight's topic is productivity implications and testing challenges on moving to microservices. Our guest speaker is Jeff Allison. So hope everyone's doing good this evening. And before we introduce the guest, I just wanted to give you some information about our chapter. SF Bay ACM chapter was founded in 1957. It is a professional association for computer professionals. And our charter is to promote knowledge of modern computing. We also have a place to create community, to support through networking, and to promote hiring. We encourage everyone who is a software professional to please support us by joining our chapter. You can go to sfbayacm.org and there's a join button. Typically every month we have 2 meetings. One of them is the general computing, typically the 3rd Wednesday of the month. The second meeting is data science special interest group. Typically that's on the 4th Monday. And also from time to time, we do have job announcements, and we can host with other professional groups such as IEEE or ValleyML.ai. So at this time, I would like to ask our friend Sean Murphy, who is a friend of our chapter, to please introduce tonight's guest.
Hi, my name is Sean Murphy, and I'm going to be the voice of the audience tonight. I'm first going to introduce Jeff Allison. Jeff Allison has 30 years of experience in the high technology computing and networking industries. He's held various roles in hardware engineering, marketing, and engineering management. He has a proven track record of developing high-power, cross-functional teams to solve complex engineering issues and drive methodology changes throughout the organization. In 1992, Jeff joined Cisco as an engineering manager at a time of dynamic growth in the company and the networking industry. He spent the next 20 years focused on customer satisfaction, product quality, and development methodology. As a VP of engineering, Jeff developed trusted business relationships with many of Cisco's major customers. Reflecting on his career at Cisco, he noted that as a manager, his focus was on product features, functions, and capabilities. As an executive, his focus was on providing value for the customer's business. Jeff graduated from the University of Wales in '84 with a degree in engineering. Jeff's goal for this talk is that it's going to be an interactive presentation. Please use the question feature in Zoom to ask questions at any time. I will speak them aloud so that Jeff can address them. Mike, I think you have to stop sharing to let Jeff share.
I got it, Sean. Can you see it?
Yep.
You can slideshow. Well, hi, everybody. So, Sean, thanks for the introduction. Appreciate you spending some time with me tonight. I know it's, I'd much rather do this face-to-face, but, you know, we're in strange times, and I'm glad we have technology that can allow us to do these kinds of things still. So, again, Sean, thanks for the intro, and thank you guys for inviting me here. This is kind of what Sean talked about, so I won't reiterate that. So here's the outline. So I've spent a lot of time in high tech and driven a lot of initiatives through enterprises, from, you know, starting in small groups and going across functionally and working different issues at the corporate level. For the last couple of years, I've been lucky enough to spend some time with a microservices startup called Traffic Parrot. These guys are I've been working with them and their customers. I've learned a lot about microservices in the last couple of years. And last year, these guys put together 3 papers. And these papers are online. I listed the links here. They basically put together a series of technical papers that would outline strategies to migrate or start using microservices. So I looked at these papers and I said, well, I'll take a look at them, and I need to create for myself an executive view because they're very technical. And I wanted to create a kind of high-level top-down view of, what microservices are, what are the issues in migration from an executive viewpoint. And this presentation is about that. It helped me get my arms around the issues. And I think it will also help other execs if they're trying to figure out if they should go this route, what framework or what approach they can use to start this journey. And like Sean said, if you got questions, please put them out there. I'll do my best to answer them. I'm not the most technical on some of these issues, but if I cannot answer them, we'll get back to you, quickly with an answer. But please don't let that stop you from asking what's on your mind. Okay, in terms of definitions, so here's my definition of monolithic applications and microservices applications. Monolithic is, I grew up with these things, starting through the 80s all the way through, to current days. I'm very familiar with the architecture, being very centralized, and familiar with understanding the issues around that. The monolithic is built as a single unit, and it's a centralized architecture. The microservices application is built very differently. It's built with small self-contained services that by definition are independently releasable. But they basically do the same thing in terms of business logic. They automate business rules, and this forms the business logic for the applications. And the business rules can be very simple or fairly complicated. They could be, how to validate a user, how to calculate tax on a purchase, and how to ship things. So that's my basic definition of microservice. So one of the things that I learned was that not all applications need a microservices architecture. In fact, sometimes if the complexity doesn't warrant and you try and do a microservices architecture, it probably turns out to be more costly than developing, a monolithic. So one of the things I took a look at is, what can you look at to determine whether you should, stay in a monolithic state or go to a microservices architecture. So I look at things like application complexity, size of team, and then business requirements. Now, size of team, there's a lot out there on this, and it kind of makes sense. I mean, anyone that's been in tech knows. I mean, the larger the teams, the more difficult it is to get collaboration. And there's some number here. So the numbers you see is anything between 20 and 70 people. That might mean you need to go to a more microservices architecture. So that could dial here, right? So you stay mono here, get to 70 people, and then you look at doing a microservices architecture. Application complexity is a little different, and you probably have discussions inside of your organizations to kind of define what that means and where would you draw that line. So you could look at, for example, like the number of business rules. You could look at number of lines of code. You could look at, I don't know, a bug count. You could look at frequency of features. I mean, etc. There's a whole bunch of things that you might get together and kind of decide, hey, once we start seeing these things, then we would go from a mono to a micro architecture. Business requirements I view as, what is the customer looking for? What does the customer need from your offering? What's important to them? Is it important that they get continuous releases? Is it important that they be able to get an update of just a feature or a function without impacting all the other features and functions? That will help you decide whether you stay in a monolithic or in a microservices environment. So what's promised? Well, excuse me, let me go back. So if you do decide to go microservices route, what's promised over monolithics? Well, what's promised is a lot, but you promised speed, scale, responsiveness, and lower cost. I think the lower cost is over time. I think in the beginning, costs are going to be high because you're going to have to invest some dollars and some time to make a microservices methodology work in your company. These do come at a price. They don't come free out of the box, but these are things that you're going to get if you decide to go on a microservices route. Now, I need to map these to something that I can talk to in my company. And, all execs talk at the corporate objectives level, right? We talk about these. We're measured by these. We're bonused by these. These things help us drive strategy. These things help us pull the organization together around common goals. So these are our corporate objectives. Whatever you're doing inside of your organization, you need to tie that to these corporate objectives. So things like speed, scale, responsiveness, and lower cost, I have to tie to some corporate objective. Otherwise, you're going to have a really, really hard time justifying it and a really, really hard time getting budget and resources to make it happen. This is what I call the executive translation. What's the value proposition? And these fit in really well and I picked these objectives. These are ones that I've used in the past. They make a lot of sense. I mean, a development methodology and product architecture that will scale to meet customer needs. Well, I get those from these values I get from a microservices architecture. Predictability is a big one. I mean, being able to, if I look at responsiveness, being able to respond to a customer request for a new feature, and I tie dollars to that feature, and knowing that I can just ship that feature and all I need to do is test that feature and I will receive revenue for that, that's beautiful. Time to revenue is something I look for. If I have to scale the product, the customer's having a problem with a feature or it doesn't do what it's supposed to do. If I can determine that problem, fix that problem, get it to them in a fast turnaround time, that's my time to customer sat. Customer sat is important because all of us as execs are measured on that. And the organizations are bonused on it too. So these things kind of tie together. They make a nice story, and I start to sew things together so I can take this now to the budget meetings, and I can say, hey, this is if we get on a microservices bandwagon, these are the things we're going to get out of it in terms of objectives, and then I can start talking about the kind of dollars I'm looking for, kind of the help I'm looking for, and so on and so forth. Okay, so we talked about this a little bit. Why is it difficult? Well, there's a lot of moving parts here, and you have to look at them all. This is what makes it not only difficult but also very exciting, because you're going to have to kind of put a lot of thought behind each of these areas. In the product architecture, you're going to get map business rules to services. So you're going to, that should be pretty straightforward. And then you'll end up with a number of services. I mean, and this could be in the hundreds or even in the thousands. I mean, there's a lot of business rules in some maps, and they all have to be coded up to provide the business logic. One thing that I heard a lot was that this is important. You need to assign architects to manage and control this stuff, right? Because especially the architectural level, you need people, a small team or a small group of architects to understand the overall architecture of this distributed system. and they manage and control it. You just can't have people, release new services as and when is needed, without some level of control and management. That's absolutely critical to establish that process and put people in charge of that. On the development methodology, you're going to get into training, and you're going to get into how to train people in new design and development processes. This is, dollars and also time, because you need to put something in place to make that happen. In design and simulation tools, you're going to have to onboard these and again, get up to speed on how they work and how to use them effectively. On test and release strategy, this is kind of key. So if you're looking at the distributed system like this, and you want to enable continuous releases, which is actually a very attractive proposition for anybody that's delivering value through software, you've got to invest a lot in automation. It's not a manual process. You can't put this into an Excel spreadsheet, and one person can't get their head around everything that's going on and kind of manually do it. It has to be automated. This is not easy to do. This is very difficult, but it's key. Excuse me. This is key to the success, to leverage the power, the advantages you get from this distributed model. Organizational structure is a huge thing. This is what.
Just before we move on, we got a question on, can you offer some examples of customers who really who don't need or don't want?
You were breaking up there, Sean. I couldn't hear the question.
Sorry. The question is, what examples of customers and what examples of customers?
I'm still not getting it, mate.
Well, Sean, do you have YouTube or something else open at the same time?
I can read the question.
We're getting feedback.
Jeff?
Yeah, go ahead and read. Yeah, that's fine.
Yeah, I'll read the question.
Sure.
What are the examples of customers who want to continuous release, and what are examples of customers who don't want that?
Okay, so I can't talk exactly to that. Customers that we're working with, they haven't gone to continuous release. My idea was, if you do have someone that needs that, because they want to be leading edge, they want to always use the fastest and the best stuff, then you can do that.
So just a voice check. Am I working better now?
No, you're working much better.
All right.
Yeah.
All right.
The other folks that don't want to go to any kind of continuous release, and I've worked with them, is when they've locked down a version of software that they're using in a production environment, and they don't want anything to change. Because if you give them something new, then that's new to them, and it kicks off maybe a regression. It kicks off a lot of check-in, and they won't change because they've committed project schedules to using that piece of software. It's very difficult for them to change midway, not unless it solves a catastrophic problem.
Jeff, one example might be medical devices with embedded technology,
you're not gonna mess with that. I mean, midstream, you're gonna have some kind of process where you can, maybe test in parallel and then cut over time. But there's, based on industry, there may be a different level of comfort being able to take change. The changes that what I was familiar with when we needed to make changes in code at Cisco, the big problem was that because it was a monolithic type central structure, it would kick off these huge regressions. There's a problem for our customers, right? Because it takes them time, which causes delays, and delays have a huge business impact. So back on this organization, a lot's been talked about this with Conway's law. And so, everybody kind of knows Conway's law, but organizations design systems that mirror their own communication structure. Well, you're right back in this song. So if you've got if you've got a decentralized architecture here and you've got an organizational structure that's central, you've got a problem. And it's hard, believe me. I've tried to break down higher level organizations or more central organizations into smaller manageable blocks. The inertia there is huge. It's a very tough problem, but you've got to figure out how you manage that if you're going to go this way. What we did observe too is that some companies couldn't do this too well, and they ended up with a distributed, monolithic, which causes maybe more problems than they were trying to solve in the first place. So those are my thoughts on that. Wanted to talk about some of the risks. I talked about governance a little bit on the you need people to manage the kind of introduction of new services into the overall structure. I didn't talk about security. Security is, in my mind, a big issue. So if you look at the decentralized microservices structure, you've got all these services and they tie together with what they call APIs. Well, each one of these interfaces is a security issue. So the governance body or this team of architects, they also need to cover the bases on terms of security and make sure that they've done everything possible to minimize the impact of anything breaking into these structures and causing a security issue. The other thing is these things are massive, right? I mean, and in some ways, that's what you want. You want to create an environment where you can very, very quickly introduce new features and functions, but you've got to have enough telemetry data to diagnose issues in this distributed system. You can't manually track it, like I said. This is not a spreadsheet operation. You need tools to be able to give you visibility in what's happening in the structure. Lack of infrastructure. I mean, if you're not making the right investments and you're not doing the right level of test automation, then any efforts you have to scale microservices are going to be really, really hard. So up front, you have to do the heavy lifting. Do the heavy lifting up front, you'll benefit at the back end because you've done the good work. And then we did talk about Conway's law. Communication patterns between teams. There's also that two pizza thing, right? With Amazon, they say if you can't feed the team on two pizzas, then the team's too big and it needs to get smaller. So there's a lot around that, and I do agree that smaller teams move a lot faster. My experience with that has also been with organizations, right? I've seen decentralized organizations move very, very quickly over more central groups, but I've also seen the challenges in organizing and managing decentralized teams because there's a lot of moving parts and everyone's moving lightning fast. Okay, so I wanted to take a look at costs here. For cost of a monolithic versus a microservices methodology. On one axis, I've got development costs, and then on the horizontal, I've got product complexity, number of services. So, I think you can kind of make sense to everybody as you start off development. You get some knee in the curve because you add in more services, add in more features. It's going to cost you a little more money. What's that look like from if I was to start a microservices methodology? Looks a little different. What I want to get to is this point here, where intuitively I know I'm adding more services. Fine, my costs are going up, but it's kind of flat. It's flat. It's more flat than the monolithic one. So that's my goal. The problem I've got here, I can change the color. The problem I have here is that I don't start off at zero cost, right? I need to make some kind of investment in terms of dollars up front. So the things we've talked about, I need to educate ourselves on development methodology and train. I need to bring in new tools. I need to figure out what my strategy is. I need to understand what I need to do to the organization. And I need to map out my product architecture and put structures in place to protect myself from lots of changes and rapid growth in my code base. So there's dollars there, yeah?
So Jeff, there's a question. You're showing the trade-off here kind of between complexity and development cost. the question is there a difference in reliability between monolithic and microservices applications?
I believe so, because if you look at it from a test perspective, and trying to measure reliability in a big monolithic, right? And you're looking at individual components. It's a lot harder to validate the complex interactions internally to that structure. People generally look at the inputs and then just watch the outputs. Whereas with a microservices architecture, you have full visibility and controllability and observability between all of those different components. So inherent by definition, the ability to better control and better observe gives you faster time to observe a problem and fix any kind of reliability issue.
Okay.
So my thing here is, so there's two big takeaways here. First of all, there's some dollars involved, and they could be significant. And then there's this, we're not going to realize any benefit for some time, right? So, and that's always a problem. You go try and get some dollars to do something, and significant dollars. I mean, you may, and you say, well, you're not going to realize this until down the road. Always gets people's attention. So this is important. And why is it important? Because you need to set expectations. You need to set the expectations correctly up front so that people understand that my ROI doesn't happen until somewhere in the future. And this is where you have to do the planning and put some kind of schedules together. Along the way, you're going to look at milestones, right, to see if you're on track. But at some point, you're going to have to say, okay, it's going to take us, I don't know, 12 to 18 months, or it's going to take us 3 to 6 months. Whatever it is, this is what you start to put together in terms of communicating what the impact's going to be to the company over time, and when we're going to start to realize that we're on this trajectory. So big takeaway here was to set the expectations so that there are no surprises. And I'm checking another look at cross-referencing team size here with product complexity. Let me build this one out. I'm assuming here that we've made an initial investment in microservices so that if I've got a microservices methodology going along and a monolithic, they kind of follow initially the same path. As complexity increases, so does team size. I'm making that assumption here too. That's not always the case, I understand, but that's what I'm using here. And at some point, the velocity is going to slow. And, it's kind of intuitive too. Why is it slow? Well, it's slow. First of all, it could slow down because if you need a lot of people, which some of these monolithic infrastructures tend to attract, large groups. First of all, you have to find enough people to attract and hire, which is not always easy. The second one is if you kind of think about what's going on in a central structure, you bringing people on to work on these components internally. They need to understand how the whole thing works, right? Because this may be dependent on that, may be dependent on that. They also may not find people that can tell them how it works. I mean, some of these systems have been out there a while, right? Documentation might not reflect reality. People that worked on it are no longer there. So, these new folks, they become pretty creative. They start to think about, well, I think it works this way, so therefore I'll do this, or I'll put a wrapper around it to make it more understandable. Whatever it is they do, the curve for learning is up. It takes a long time to get their arms around what they're supposed to be doing. In a microservices architecture, that's not the case, right? Because it's decentralized, and this is where you start getting the benefits of a decentralized structure. I'm trying to do something new over here. I don't care too much about this. I don't need to know how that works. I need to know what goes in and what comes out, and I need to know what my business rule is. I need to code up, and then I'm off and running. I can do this with 6 people, 4 people, 2 people. I'm empowered. I do my dev, test, release, and build, and off I go. So a simple definition here, that is a lot faster in terms of getting stuff completed over a monolithic. Okay. All right, I'm going to change up on you a little bit here. I'm going to talk about test, and I did talk about it a little bit on the previous slide, but just to run through this slide, if this is your software to test your software, you need a test strategy, and the strategy needs to involve both a combination of real resources and virtual resources. And by real, it's kind of what I mean. You know, real resources are other pieces of software, third-party third-party stuff, dependencies or hardware, something that's real. Virtual is something that emulates the behavior of a real resource. And why is this important? Well, sometimes the real resources aren't available to you. And what you're going to do? You're gonna wait? No. You've already invested in this decentralized model to make you move fast. Why are you going to wait on a resource to test your stuff? Because it's just going to slow you down. So you invest in technologies that allow you to emulate the behavior of a real resource because it's not available or hasn't been written yet. This takes a lot of work and a lot of investment and a lot of expertise, but it's critical if you're going to continue to develop quickly. And let's talk a little bit about them. I'll just build this one out. These examples of real resources. So, you know, I'm here. I've got to, you know, develop, test my code. I've got to use, you know, these servers over here. I've got some third-party stuff over here. So I start putting all these real resources together, and like, you know, can check out my code at some level. I've also done other kinds of tests, but I needed to do this. One of the problems with this too is that, you know, some of these hardware dependencies, you know, this hardware might not always be available to me. When we were developing some really high-end routing technology that cost a lot of money, I mean, a huge amount of money per unit, we only had so many. We had to then go to a 7x24 model and kind of schedule developers' time on it. We tried to come up with a virtual emulation of that box to help out, but that was very, very difficult then. So I totally realized, you know, and as an exec, it's kind of, you know, you just don't want to put anything in front of engineers that's going to slow them down, especially if you can kind of solve it. I mean, you just want to take away any barrier, and not being able to give the right level of resources to an engineer at the right time is, you know, is something that constantly we're working on so that we could get the throughput that we wanted to realize. So in this case, if I needed to add more and more hardware dependencies and I couldn't do it, then I would look at these kind of virtual resources to kind of emulate the hardware. So I could then pop these down here as kind of pseudo emulation devices, and you know, it's all done in software, right? So I can put as many of these in as I want in front of any number of engineers that I want. So I'm removing that bottleneck. So that's what I'm saying. When it's difficult to scale real resources as the system complexity increases. Also, these virtual resources here, there's some things that you can do with using a virtual resource or emulation of some real device that you can't do with the real device. If you had to run against a real device for a certain amount of time before you got to the point where you wanted to test out some new feature, that's a waste of time. If I had a virtual resource, I could just jump straight to that point and then test from there. So there's a whole bunch of stuff around this that, you know, I'm not covering here. I just wanted to give people a sense of, in a distributed model, you're going to need some kind of advanced simulation technology to help you use the methodology through your organization.
So Jeff, somebody wants to give you a promotion. The question is, if Jeff was in charge of developing Microsoft Office.
Okay.
So if Jeff was in charge of developing Microsoft Office from scratch, the desktop version, not the cloud version,
okay,
would you use microservices or monolithic?
I'd use microservices.
Okay. All right. You want to elaborate on that at all?
Yeah, I just think, when I've ever used Office, right, and there's always been like a problem with something or other, right? So some feature, some function that either isn't there or doesn't work, and then I've got to go reload the whole base to get that to make sense. I'd much rather if there's a new editing feature that comes up, let's just take that and add it to what I've already got. I mean, maybe that's just my approach to things. Maybe other people are more, hey, make it one big, monolithic, and then just, cut a new release every 6 months.
The question was what you would do if you were in charge.
Oh, if I was in charge, no.
Yes.
I'm fully on the microservices boat right now. So,
all right.
I think also, I didn't touch on this so much, but it's. And I'm not taking anything away from monoliths. I think that they're here to stay, and they'll always be here to stay. And I think that attracts a certain expertise, and microservices attracts a certain expertise. So I would also look at the organization and say, okay, well, what core competencies do I need inside of my organization to scale and to do new things? And microservices might be one of those core competencies. So that might help me kind of, get my head around what architectures I promote going forward. So how to get started here. So there's this thing called Greenfield. So yeah, you can start with a microservice, but there's a lot out there that you can read that'll tell you if this only makes sense if you've already made the investments in the microservices methodology, right? All the things that I talked about, you've kind of got a handle on, and you've got the abilities to do this. And the consensus is, if you don't, then you should start with a monolithic, and then plan to go to a microservices architecture later if you need to. And this comes back to these dials, right? So the nice thing I like about this approach is you can use this monolithic, and you probably get out there much faster. You can use it as a fast prototype, right? So you could be out there with this monolithic thing, and you could be making lots of iterations, understanding what people are doing with it, how they're using it, come back, modify it, and start looking at your dials. Looking at my dials here, how's the complexity looking? Am I crossing the boundary? Am I crossing the boundary? Am I crossing the boundary? And then you say, I'm crossing the boundary, I need to go to a microservices model. So the only problem with this is it's too serial. I mean, what you need to be able to do is you need to say, okay, I'm running along here with my fast prototype, this monolithic. I imagine maybe at some point I need to change to more of a microservices. Let me measure along the way and kind of predict. And if I think here, I'm going to need a microservices architecture, I start doing it right here. Oops, sorry. Okay, and at this point I'm parallel. Okay, I've got a monolithic app and I've got a microservices app. Microservices app's not ready for prime time yet. I'm working on it, but I'm in parallel. When I get to this point that I'm measuring, I'm using some indicators here, I just cut over. And I think that's the way in which you should kind of use that. Get out there quickly, get some feedback, understand it's going to go that route, start working in parallel, and then cut over. There's no disruption to your install base. Then you're off and running, and you're realizing all the benefits you get from this architecture. The issue here is parallel, right? That's always dollars, more people. Okay, another way to get started is continue to ship the current model. You got this thing, it works, ship it. Anything new, make a microservice. Now, this may be more difficult for some features, and I'm absolutely sure of it. But conceptually, I look at this and I go, "Oh, this is great," especially if I'm in the situation where I've installed this at a big customer. They're very happy with it, and they want one new feature. They want this guy. And I put this back into the monolithic, they're going to say, oh my goodness, now Jeff, I got to go build a test bed. I got to regress this thing. I've got to put people behind it. No. Then I say, well, what if I don't do that? What if I give you something that's just, fairly what you actually want? Just test that, because all the other stuff I haven't touched. Your regression is much simpler. I think this is, and that just makes sense. These could be on a different release cycle. This monolithic could be on a 3, 6, 9 month cycle, whatever makes sense. This thing could be every day. So this is a great way to get started, I think. Along the same lines, let's see. Along the same lines, instead of instead of adding something new, pull something out. So, I've always had a problem with this thing in here, this component. It's painful, it causes a lot of problems, so I need to change it often. And changing this often means I'm changing this often. Why don't I just pull it out of here? And then all this stuff that, I don't need to change often stays the way it is. This stuff is shipped and developed and coded up with the microservices methodology. It just works for me again. It's these are on different release cycles, and this is daily. It allows for
Jeff, we got a question on this. So in practice with microservices, do you end up with a large number of legacy versions, or do the older versions get pruned more?
That's a good question.
That's a good question.
I don't know, actually. I would think that I would hope that they would get pruned more. But I think it's highly dependent on what's changing. So I don't have a good answer to that one. That's a good one to take.
So in cloud, the old ones would get reaped. The delivery would overwrite them, right?
Yeah.
But in on-premises, it looks different.
Yeah. Because and this is what I was trying to get to too. It's like everybody wants. If you've got a code drop and it's stable for you and it's working, you want to keep that. And you find out that there's things that are not stable. That's the only thing you want to have changed. And if there's ways to do that without disrupting the rest of the logic, that makes sense. So I don't know for sure. That's a good question, though. Thank you for that. Okay, and then finally we'll talk about this is the test migration strategy. So everything I talked about with microservices for testing and virtual resources could be done with monolithics too, right? And this is the big deal. So here, say this database here is something I need to schedule time on. Maybe it's a production database and nobody wants me to mess with that when I'm doing my development, and I've got to kind of do it after hours or whatever, because I can't get another environment because it's too expensive and I could emulate that database using a virtual resource, and I'm just off and running. So same thing for like a backend or a third-party service, I can do that. So the stuff I talked about with simulation also works with monolithics. Okay, so some key points and takeaways. Not all applications need to be microserviced. We talked about that. There are many ways to start. Start with a monolith first and then go to a microservice. You can add features or replace components. We just talked about that stuff. Here's the heavy lifting here. Expertise comes with experience. You're gonna have to invest in that. Probably have to hire, then have training programs in place, and also then support the new tools and new infrastructure, which is basically the dollars. You need to plan carefully and set expectations. So this was the ROI and the budget. Nothing comes for free. Things do take time. It's important to set the right expectations up front. it's important, especially if you're in an environment where you're competing for dollars. So say you're an exec and you're in there and you've got this budget you want to develop a microservices methodology for this application, Microsoft Office or something. And then you've got another exec that has another project that is, monolithic, and he can start right away. Those discussions become very interesting because he may be able to start right away and start bringing in revenue, but that might tail off or have problems later on. You won't be generating revenue right away because you need to get up that learning curve. But at some point you will, and at some point then you need to argue that you will be more profitable than the monolithic that you were competing against for that budget. These discussions actually do happen a heck of a lot. Okay. So that's the end of my presentation. Are there any questions?
So we do have one.
Okay.
Can a desktop operating system and a web browser be developed with microservices? If yes, please explain how this is possible.
I don't think so. Yeah, go ahead.
So you can use micro front ends on the UI side.
Yeah.
Microservices depends on what they're doing on the server side.
Yes, I absolutely. Yeah. So, good question. The world's not going to go on microservices tomorrow because a lot of applications it doesn't make sense. The same way that you have different structures in organizations. I mean, I know of a lot of organizations that are very centralized and very successful, and they will be very successful for a long, long time. I know others that are decentralized that work very well. I know some that are decentralized that are totally, they just fall all over themselves because they can't figure out, who's doing what. They need a level of command and control. I've seen matrix organizations where they try and do both, and that's a total disaster. So
here's a developer who's he says, as a developer, I see execs falter in estimating tooling and infrastructure upfront costs.
Yeah.
Can you please highlight what are the essentials? So what are the key elements that you use to estimate your infrastructure and tooling costs?
Well, I actually take a lot of input from the developers, right? So it's not me going out and back of the napkin thing. It's actually talking to other people that have done it. So understanding what their costs were, talking internally, and then kind of getting together and figuring out what this actually means. It's hard. I'm telling you, and these apps, you're absolutely right, mate. A lot of execs will go in and they won't go in with the right numbers, and it becomes an absolute nightmare over time because, it's probably still a large number, but should have been just much larger than that, and expectations are set very wrong, and then you're behind. You're always behind. You're never in front of it. So it's a hard one, but I try and reach out to others that have done it to get some get some of their guidance, and I also reach out internally. I've also found that some of the suppliers of some of these tools and infrastructure, they sometimes have models that can help you based on their customers that they have. So it's a combination of things.
So there's a question: does microservices need more design decisions frozen up front at the beginning, where you have less chance to try something and modify it?
I think you can. I think the way I look at it is you can. I don't think you want to lock down it too rigidly because you need some flexibility. I guess that's what you're trying to lock down. If you want to lock down, I think that some governance around security for sure. That is important. So if that constrains you in some way, then I think that's okay. But for other things, I don't think so. There just needs to be a well thought out architecture. It can't be, I've seen systems. It doesn't really matter whether they're developed in central groups or decentralized groups, that the architecture is really not thought out up front, and not thought out in terms of scale, not thought out in terms of performance, not out in terms of capabilities. And so I think in either using microservices or monolithic, you really need to nail down that kind of level of the architecture.
Okay. So you're distinguishing between architectural decisions and then delegating other decisions to designers. I think the question around less chance to try some modify it is, so in your approach, where would you see experimentation or prototyping take place? Would that take place prior to freezing the architecture?
Yeah, I think so, because you have to have some way of kind of validating and verifying what architecture you're looking for. So there needs to be some either fast prototyping or some kind of simulation of what that's going to look like over time. So I think you do some discovery that way.
Got a question. What's your opinion about third-party microservices? Are there good building blocks to reduce the learning curve up front?
Is what do you mean by that? Third party, someone that can help you get onto the microservice?
So we can ask, are you talking about building blocks, or you're talking about consultants to the person that asked the question?
Yeah.
Building blocks.
Well, building blocks. So he's talking about pre-configured building blocks.
Oh, so that's somebody else's IP?
Yes.
Yeah. Okay. Yeah. So if I don't know too many of these guys, but I can tell you in general, if there was something that I could get off the shelf that would push me down the road further on my schedules, I would go for that. But I can't comment on the guys out there that are doing it, if they're any good or not. I'm just telling you in general, if there's something I could get off the shelf, that's what I would do.
Yeah, I think part of this may involve things like the built-ins that come with Azure, the built-ins that come with AWS, where you the trade-off may be lock into a particular cloud vendor.
Yeah, I wouldn't want to do that. So it would have to fit in with my my overall strategy. I would not want to get locked into anything like that. I want the flexibility to go to different kinds of clouds and so on.
So a question from a developer. Microservices are so new, but so many job openings ask for experience in them. Do you have suggestions to apply for jobs like this and defend yourself, that you worked in Monolithic with some training, you'll be fine with? So I think the question is, microservices are new, but jobs are asking for them.
Yeah.
Should he stick with Monolith, or should he bite the bullet and move to microservices?
It's a good question, and more personal too, right? In terms of what you want from career and advancement and stuff. If it's believable that microservices has more of a future than monolithics, then absolutely. And I think maybe tune the resume into things that you've done in the past that kind of have a more decentralized flavor or view to them, or show in the past where you've been able to master a technology and then remaster another technology, so you have the capability to do that. I think that's probably a good way to how you present yourself, that you can go to a different methodology because you've done it before. You have that ability.
Is there a more general question there that over time your skills are there's going to be new technologies and new methodologies, whether we call it microservices or whatever. I think at some level you've got to master the ability to take a step back to take two forward.
Sometimes, it's hard though. I mean, and it's hard when you see these things out there and they're looking for all these capabilities, and how do you get a foot in to start to master them and get on that wagon. So
well, the questioner found that answer helpful, so
good. Good. When I was hiring people fast and furious back in the day, you know, I couldn't find people that had the experience I needed. I mean, because it just didn't exist in a lot of places. I had to look at whether I felt they could get there, and a lot of them did. So there's different things that hiring managers should look at and execs should look at. It's not always true if someone has the experience that they're any good at it as well, right? I mean, I hired people who were supposed to be able to do this, that, and the other, and they couldn't.
Well, I think we're about out. Oh, so question, what prior experiences are most helpful for making the move to microservices?
Prior experiences. Well, mine has all been the issues around monolithics, right? And that's just my personal experience.
So certainly comfort working with APIs, working with code that you're not able to go in and edit.
Yeah. Just seeing total frustration sometimes that you know, the problem seems so massive you can't even get your arms around where to start. Customers struggling with taking on releases that all you really needed to do was fix one bug, and now they have to, you know, go through a whole revalidation of the whole thing because you may have broken something somewhere else. I mean,
so question is, microservices just a rebranding or a new name for web services?
I mean, at some levels, I could buy that, yeah. I mean, I don't think this idea of, you know, modular design and everything else, and, you know, keeping interfaces simple and, you know, kind of dividing and conquering, I don't think that idea is new. It may have taken on different names over the years, but I don't think it's new.
Cool. Well,
so a couple of things.
Go ahead.
Go ahead, Sean. Sorry.
No, I was just going to ask if you had any concluding remarks. I think we're about out of questions.
No, I just thank people for coming along. It's been a strange couple of weeks with this weather and everything else and power issues. If take a look at the traffic parrot stuff, if you like it, reach out to those guys. And if you have any other questions or you want to reach out, just feel free to, you know, drop me an email. I'm happy to have a discussion or just, you know, kind of chat. So I appreciate all of your people's time. Thank you.
So I think we're going to turn it back over to Mike.
Do I need to get out of sharing, Mike?
Yeah.
I'm out of sharing.
All right. Well, thank you, Jeff, for that very insightful talk on microservices. Really appreciate it. Can we do Q&A? Does anyone have any Q&A? Can you raise hands? Give you a few moments for any questions that might come through.
We took a lot of questions as we went, Mike. It's possible we've exhausted the depth and level of interest that people have in this topic, but you know, we'll go to midnight if needed. But you know,
yeah, they're good questions actually. We caught all those, right, Sean?
Tom says there are no YouTube questions. Yeah.
Okay.
All right. In that case, we can end it, and just thank everyone for attending and supporting these talks, and look forward to meeting you again in our next upcoming ones. All right. Thank you very much.
Great. Thanks, guys.
Thank you.